Picture this. You walk out to your driveway on a Tuesday morning, and there is a dark, spreading stain underneath your Toyota. You crouch down, you touch it, and your stomach drops. That is engine oil, a lot of it. You pop the hood, and you can see it. A thick, greasy river of black oil cascading down the side of the engine block, pooling on top of the transmission bell housing, coating the underside of your car in a layer that looks like mechanical catastrophe. You drive it to the dealership because you trust them. You sit in that waiting room with the paper cups of bad coffee, and 30 minutes later, the service advisor walks out with a clipboard and a very serious expression. He sits down across from you and says the words that have drained the bank accounts of Toyota owners for 20 years: blown head gasket, rear main seal failure, possible internal block damage. The estimate he slides across the table reads $2,200. And here is what he does not tell you. Here is what nobody in that building will ever tell you. The entire terrifying oil hemorrhage you are looking at is coming from a rubber ring the size of your thumbnail, a $4 rubber ring, and the whole repair takes 15 minutes in your own driveway. Stay with me, because what I am about to walk you through is going to change the way you see every Toyota oil leak diagnosis for the rest of your life. We are going to go back to the engineering rooms where these engines were born. We are going to follow that oil trail to its true source. And then I am going to give you the exact step-by-step method to fix it yourself this weekend for $4. The industry has been counting on you not knowing this. Today that changes. To understand how a $4 part can mimic a $2,000 failure, you need to understand how oil moves inside a running Toyota engine, specifically the engines that made Toyota's reputation. The 22RE, the 3RZ, the 5VZ, the 1UZFE. These are the motors that carried millions of Tacomas, 4Runners, Tundras, Land Cruisers, and Camrys through the 1990s and into the 2000s. Toyota built these engines with an almost obsessive commitment to longevity. The internal tolerances were tight. The materials were selected for thermal stability. The oiling systems were robust and pressurized aggressively to protect high-wear components even under brutal conditions. That aggressiveness is exactly the detail that becomes important in a moment. Inside every one of these engines, oil is not simply dripping passively through the motor. It is being pumped under real pressure, typically between 40 and 70 pounds per square inch at operating temperature, through a network of internal galleries machined directly into the aluminum cylinder head and the iron or aluminum engine block. Every moving component that lives inside that pressurized oiling network is constantly bathed in a continuous high-pressure film of hot oil. The camshaft is one of those components. It sits at the very top of the cylinder head, spinning inside its own set of precision-machined journals, fed constantly by pressurized oil delivered directly from the main gallery. That oil lubricates the cam lobes as they press against the valve train with hundreds of pounds of force thousands of times per minute. The pressure at the camshaft is real, it is constant, and it never goes away as long as the engine is running. Now, on most of these classic Toyota motors, the ignition distributor is driven directly off the front of that camshaft. On engines without a distributor, a blanking plug or a cam sensor housing sits in the same location, threaded or bolted into the top of the cylinder head at the precise point where the camshaft terminates and exits the head casting. This is a simple, elegant, deeply practical design. The distributor shaft slides directly into the cam drive. The whole assembly is held in position by one or two 12mm bolts, clamping a small hold-down bracket to the cylinder head. Simple, brilliant, and completely dependent on one small round rubber O-ring seated in a machined groove on the shaft to keep all of that pressurized oil from escaping to the outside world. Think about what that O-ring lives through every single day. Every time you start the engine, that rubber seal goes from ambient temperature to over 200 degrees Fahrenheit within minutes. Every time you park, it cools back down. Heat cycle after heat cycle, year after year, for 15 years and 150,000 miles. Rubber, even the best petroleum-resistant rubber, cannot survive that indefinitely without maintenance. The chemistry is straightforward. Prolonged thermal cycling causes the polymer chains inside the rubber compound to break down and cross-link in ways that eliminate the material's elasticity. The O-ring stops being soft and pliable and begins to behave like hardened plastic. It shrinks very slightly. It loses the ability to conform and seal against the aluminum bore it was designed to press against. And the moment it loses that conforming pressure, the 40 to 60 pounds of oil pressure inside the cylinder head pushes right past it. Oil begins to escape around the distributor shaft. Not a drip, a pressurized weep that becomes a flow. Here is where the illusion happens. And this is the part the dealerships are counting on you never figuring out. When that oil escapes from the top of the engine, gravity and fluid dynamics take over completely. The oil does not pool neatly at the distributor. It runs. It follows every contour of the engine block downward. It travels along the back of the head, over the rear of the block, and begins to coat the engine's lower rear sections. It reaches the junction between the engine block and the transmission bell housing, which is exactly where the rear main seal lies. It saturates that area. It drips from every surface in that zone. 1. It pools on top of the transmission. It flings off the flywheel and coats the underside of the car in a pattern that is geometrically indistinguishable from a blown rear main seal. And when a technician, trained to flag profitable repairs, gets under that car and sees oil saturating the bell housing and the lower rear block, the diagnosis writes itself. Rear main seal. Possibly head gasket, maybe internal block damage. The paperwork goes to the service advisor goes to you, and $2,000 leaves your account. Toyota knew about this failure mode. The engineers who designed these oiling systems absolutely understood that every external interface with a pressurized gallery required a serviceable seal, and that those seals had a finite service life. The original service literature for many of these engines lists the distributor O-ring as a replacement item. It has a Toyota part number. It costs $4. In a properly functioning service culture, a technician doing a thorough inspection would identify the O-ring as the source, quote, 10 minutes of labor, and send you home for less than $20 total. That is not what happened. What happened instead is that the dealership network discovered something far more valuable than a $20 repair. They discovered that the visual presentation of this failure was so convincingly catastrophic, and most owners so completely unfamiliar with the physics of oil migration, that a confident misdiagnosis would almost never be questioned. The rear main seal became a profit engine, the head gasket became a profit engine, and the $4 O-ring stayed invisible. Think about the scale of this. In North America alone, Toyota sold millions of trucks and SUVs powered by these specific engine families between 1995 and 2008. Every single one of those engines contained this O-ring. Every single one of those O-rings was subject to the same thermal degradation cycle. Conservative estimates based on repair order data from independent shops and owner forums document this misdiagnosis occurring at a rate that, when extrapolated across the entire vehicle population of affected models, represents hundreds of millions of dollars in unnecessary repair billing over 2 decades. Commercial fleet operators who maintain their own workshop data have documented this exact scenario repeatedly. A vehicle comes in with apparent rear main seal failure. An experienced independent technician cleans the engine, runs it, and traces the oil source with a UV dye kit. The dye shows up at the distributor bore. $4 O-ring, 15 minutes. The fleet log shows the vehicle returning to service. The fleet log also shows that the same vehicle had previously been to a franchise dealership with the identical symptom and received a $2,000 estimate for lower block work. This is not conjecture. This is documented in the maintenance records of commercial operators who had the resources and the technical literacy to catch what was happening. Now I am going to give you the exact repair, not a general description, the precise, physical, step-by-step method you will use this weekend. Before you touch anything, let the engine cool completely. You are working at the top of the cylinder head near the oil gallery. A hot engine means hot oil under pressure, and you are not taking that risk. Give it at least 2 hours after the last run. Once the engine is cold, open the hood and locate the distributor. On most of the affected Toyota inline 4s and V6 motors, it sits at the rear of the cylinder head, a cylindrical housing roughly the diameter of a large flashlight, with the ignition wires fanning out from the cap to each spark plug. Before you loosen a single bolt, get a paint marker or a silver paint pen. Mark a clear reference line across the base of the distributor housing and onto the cylinder head directly below it. This mark preserves your ignition timing. If the distributor comes out and goes back in at exactly the same rotational angle, your timing is preserved and the engine will run perfectly when you are done. Do not skip this step. Now find the hold-down bracket. It is a small stamped steel clamp bolted to the cylinder head with either 1 or 2 12mm bolts. Remove those bolts completely and set them somewhere you will not lose them. With the bolts out, grasp the distributor housing firmly and pull it straight up and out of the cylinder head. It will resist slightly because the old, hardened O-ring may be binding in the bore. Pull firmly and steadily, straight upward. Do not twist it yet, just lift. It will come free. Look at the base of the distributor shaft, the portion that was seated inside the cylinder head. You will see a machined groove running around the circumference of the shaft. Seated in that groove is the O-ring, or what used to be an O-ring. In a failed unit, this ring will be hard, brittle, flat, and maybe partially cracked or missing sections entirely. Take a small pick tool or even a straightened paper clip and carefully work it under the old ring. It will snap and crumble. Remove every fragment. Clean the groove with a small rag and a little fresh engine oil. Inspect the bore in the cylinder head, the hole the distributor slides into. Wipe it clean as well. Now, take your new O-ring. The correct replacement for most of these Toyota engines is a standard metric O-ring in the 29 by 3mm range, though you should confirm the exact cross-section for your specific engine at any auto parts counter or by cross-referencing the Toyota part number from your factory service manual. The part will cost you between $2 and $5 at any parts store and can be ordered online for less. Take that new, soft, pliable O-ring and stretch it carefully over the shaft and seat it into the machined groove. It should sit flush and snug with no twisting. Dip your finger in fresh engine oil and run it completely around the new O-ring to lubricate the rubber before installation. This is important. A dry O-ring can roll or distort as it enters the bore and will not seal correctly. Align the distributor with your paint marks and slide it straight back down into the cylinder head. You will feel resistance as the O-ring enters the bore, and then a positive seating as it slides fully home. Reinstall your hold-down bolts and torque them snug. Reconnect any electrical connectors. Start the engine. Let it reach operating temperature. Check for leaks at the distributor base. You will find none. The entire rear of the engine, the transmission bell housing, the lower block, will be dry once you clean the old accumulated oil away with degreaser and a hose. The $2,000 catastrophic failure was a $4 rubber ring and 15 minutes of your Saturday morning. This is not a coincidence. This is not a gray area. The service industry in this country is built on a fundamental asymmetry of technical knowledge, and nowhere is that asymmetry more deliberately exploited than in the diagnosis of visible oil leaks. When oil is running down your engine and pooling at the bottom of the block, every psychological trigger fires at once. Fear, urgency, complexity, the overwhelming sense that only an expert with thousands of dollars of equipment can fix it. The industry designed the experience of that service bay to maximize your fear response and minimize your critical thinking. They have a name for customers like us. They call us opportunities. Share this video right now with every Toyota owner you know, not as a favor to me, as protection for them. The next time someone they care about gets handed a $2,000 estimate for a rear main seal on a 4Runner or a Tacoma, they will know to ask a different question. They will know to look at the top of the engine before they believe a word about the bottom. That knowledge is worth more than anything that service advisor will ever tell them. And if you think a $4 O-ring fooling diagnostic professionals for 20 years is a story worth knowing, wait until you see what I am releasing next. I have documentation from a former Toyota master technician that reveals how dealerships across North America are currently using a completely normal and harmless transmission shutter at highway speed to justify complete transmission replacements at $4,000 per vehicle when the actual fix requires a single 2-ounce bottle of a specific additive that costs $8 and cures the problem permanently in 40 miles of driving. That video goes live this week. Hit the notification bell before you close this tab, because there are people who do not want you to see it, and I cannot promise it will